Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam, Doktor.
Okay, today will be your last lecture of, in ergodic theory number 1. So let us recall a bit what we have learned in previous class on Tuesday. So we learned about invertible and non-invertible transformation. Okay. So if we consider the entropy of major preserving transformation, and so actually how there are three formula, right, to get the entropy, to find the entropy. So again, we consider the psi is finite and the entropy of the psi is given by this formula. Mu AI log mu AI. Next formula is the relative entropy. Okay, so we have this is equal to the limit 1 over n of the entropy of the joint. I equals to 0 until n minus 1. And the last one is the entropy of the transformation. Okay, so this is, we call it as the supremum of the set of the relative entropy respect to psi. So here in your formula, so psi here is finite partition, and you know this is non-invertible. Okay, so for in this number 1 formula, so you have conditional, right? So for conditional, you have either conditional of psi with respect to B or the element in the second partition, or you can have the entropy of psi with respect to the second partition. So for these two cases, you have different formula. So this one you take the average, and for this one you can just take the directly the formula that you want to use, which means that you have minus log something. Okay, all right. So if for the case of our example that we considered last time, so if you have x is finite and your entropy of the transformation is 0, so you found this already in the lecture number 12. So kalau you all have finite, let's say A, B, C, right? And then your psi could be the largest one should be A, B, and C. Okay, and you have all your possible in between X and this epsilon, you can find all list of possible elements, right? Okay. So in this case, you have psi is finite. Okay, then you find the entropy. So since your epsilon is finite, then you can find entropy. So you found entropy here by this psi join the t minus 1 psi join less than epsilon, and then another psi join with t inverse. So if you do that for 3 partition, 4 partition, and so on, okay, you do for how many partition until join partition lah. So I have t minus I psi less than epsilon. So if you want to find the entropy, you find the join, right? Entropy of the join is less than entropy of psi. And then you found that this limit, if you take the limit here, this become 0. Right? So that means your entropy of T is 0. So if the entropy of T is 0, then you can say that this is invertible. Okay? Okay, now for the second example, so if you have this set 0 and 1, and you consider M usual Lebesgue measure, okay, and you have the ariadic transformation. So if T inverse I gives R pre-images, then you find that your HT is equals to log R. So for psi that has this element, so you have AI is given by this segment. Okay, so here I is runs from 1, 2 until R. Okay, so you will have R pre-images. So kalau R pre-images, that means you cannot, this is non-invertible. Also the same for the case for the Bernoulli. Bernoulli shift of one-sided. Okay, so you have psi is given by this coordinate function element. So either x0 is 1 at 0 or x0 is 1. And then if you consider E I equals to E, so for any I runs from 0, 1 until so on. If I have consider R here, R minus 1 of PI is 1. So that means you will have R minus 1. Okay, this is all the elements. So if T is the Bernoulli shift, then you will have your entropy from this formula, right? This one, if you remember. So this is non-invertible. Apa maksud dia kat sini? If you look at this example, kalau dia punya entropy is non-zero, okay, contoh yang ni, Allah. Okay, yang ni you will get non-zero kan? You will have some values. In previous one also you will have some values. But in the example number 1 you have 0. Right. So if you have 0, that means your transformation is invertible. So kalau dia non-zero, that means it is non-invertible. Okay. Okay, so today we will continue with the invertible functions. So we call it as invertible transformation. So, invertible transformation. So the properties of the invertible transformation. So if T is invertible measure preserving transformation, and P is the small p, integer, then we can consider entropy of T power P is equals to P multiply with the entropy of T. Okay. Kalau entropy of T power P and P is the integer, so you can have that P tu kita boleh bawa keluar jadi macam kita darab dengan constant or coefficient with the modulus. So kalau H of T power minus 1, or we call it as the pre-image, so entropy of the pre-image must be the same. Why?
Oh, tak jadi negatif HT.
Okay, why? Itulah. Why? Sebab, so you bring this, right? Show, how to show, that means HT inverse. So you put the minus 1. Betul? Boleh?
Ada modulus, lupa lah.
So ada modulus kat depan, jadinya jadi 1 lah. Boleh? Okay, now. Another property, if T power 0, maksud dia?
0.
0 ke?
Tak.
Macam A power 0 berapa?
1.
1. So kalau T power 0, T tu transformation, bukan value. Jadi I, identity. Okay. So kalau T power 0, that means this is a identity transformation. Mana pergi tadi? So the entropy of the T power 0 is, ingat tak? T power 0 berapa? Identity. Kan dapat 0. Betul tak? Remember?
Betul.
Okay. So identity kita akan dapat 0. So kalau 0 ni jadinya dia memang invertible lah. Identity memang invertible. Okay. Next example. So proof for h t minus 1 is equals to h of t by using this join.
Memang set pada negative x
Sorry?
Join set tu idea pada negative x
Minus x.
Negatif
Tak faham
N.
soalan. Ni negatif n je tak? Ni negatif n.
Okay.
So minus n to n t of inverse psi is equals to v t of psi. T of power I psi. Ni psi tak. So kita nak prove entropy of T minus 1 is equals to the entropy of T. So we use another part, we use this V join ni. Okay. So V join ni, since this is apa? T is measure preserving transformation. So T inverse of I is equals to T of I. Dia macam measure dia. Measure of T of minus I is equals to measure of T of I. So this part dia use join tu nak show yang entropy inverse ni the same by using this. Pun boleh juga. Okay. Example. Transformation. Okay, so we have finished this part. So let T be ergodic transformation. So if T is ergodic transformation, there exists P such that your T power P is equals to the identity. So your entropy is berapa? Kalau T of P is equals to identity?
0.
0, correct. So what can you gain from this information? So kalau TP is equals to ID, so let's say I have F, let's say X, I have A. F of X, I have B. F of 2X, I have C. Until F of PX, I got A. So what can you infer from this example? You start from A, and after P times, P iterations, you got back to A. Function apa ni? You start from A, you go somewhere else, and then you come back to A. Function apa ni?
Periodic
Yes, periodic function. So that means, so kalau if you have this, T power P is equals to identity. Identity meaning you start from any numbers and you come back to its original point. So if T is periodic, so you will get your entropy will be 0 if your T is periodic. So ergodic transformation is actually periodic transformation. Sebab apa ergodic? Kalau you remember, so you have your T kan. So you have A, B, C. So A go to B, B go to C, C goes to A. Cycle. Cycle kan? So A pergi B, B pergi C, C pergi A. So dia start balik. So if you start from B, you go to B, you go to A, you go to B balik. So this is cycle. So if the transformation is cycle, so we call it as ergodic transformation. So ergodic transformation has this kind of property. So kalau ergodic transformation, which is also called periodic transformation, dia punya entropy is 0. Okay, let's try to see proof. Okay, proof entropy of T power P is equals to P HT. Okay, so you have your information H tapi tadi T of P, T power P is equals to ID, right? Okay, so you can use in your proof. So entropy of TP now becomes ID, T power P. This is equals to P multiplied with HT. Agree?
Yes.
So we know, yes, you know already your HID is what? Entropy of ID is
0.
0. This is equals to P of entropy of T. Okay, so this implies that your entropy is
0.
0. So you got your entropy 0. Boleh? So you have proved this statement. So if you prove this statement, so if T ergodic transformation, so you have T power P is equals to ID, so you have entropy is 0. So the proof is this. This one lah proof dia. Okay, so another example. Let's I have X is this segment for any alpha taken from 0, 1. Okay, T alpha X, so we give the transformation T as this, X plus alpha mod 1. Okay, so I have the transformation here. You have the X segment and then you have the alpha. So your alpha, the parameter alpha is taken from 0, 1 segment. So this alpha can be anything between 0 and 1. Okay. So we let this T alpha be the measure preserving transformation. So this is also invertible. Okay. So number 1. If alpha is 0.2, can you find your image T alpha of this function at this point? It's close. Okay, what do you get? Substitute je 0.3 tu dalam formula.
0.5 hingga 0.7.
0.5 dengan 0.7. Senang kan? So you will have 0.5 tambah dengan 0.7. Okay. What if you have T alpha 0.7 dengan 0.9? Okay.
0.1.
Boleh ke kita 0.9 dengan 0.1 ni? Sebab segmen kan dia macam ni.
0.9 hingga 1. Union
So you should write 0.9 hingga 1. Okay, and then union with
0 to 0.1.
okay, 0 to 0. 0 to 0.
Open interval ada tu.
Open.
Ni open. Okay, correct. So you will have two pre-images, two image, right? So kalau, okay, for this case, mana satu invertible, mana satu non-invertible?
Yang bawah.
Invertible.
Ya, macam mana? Okay, atas. Nombor yang atas ni invertible ke tak?
Tak.
Invertible.
Invertible. Invertible. Yang bawah ni tak. Sebab dia ada dua. Okay, contoh. If you take the image here, macam ni. If you take one of the segment here, you try to project. Okay, you try to find the pre-image of this. Dia sebenarnya kena cari dua-dua. Cannot find the pre-images sebab dia ada dua. Nak cari untuk pergi ke sini balik, you have to take both. If you want to find the pre-image of this thing, kan, pre-image, you have to take both. Because you want to come back to this segment. So that means cannot. Because you kalau invertible dia kena one to one. They cannot have two sini pecah masuk sini tak boleh. Kalau from image, kalau ini from one you got two images is fine, boleh. Tapi from one images or two images to go to one cannot. Ingat tak function punya fungsi apa? One to many, many to one. Kalau many to one apa? Function ke tak? One to many function ke tak? So one to many tak apa. One to many boleh kan? So one to many is fine. But many to one cannot. That's why ini non-invertible.
Doktor.
Ya? Yeah?
Yang TA untuk 0.9 tu, yang 0.1 tu open ke close sebenarnya? Dia punya image dia tu.
Ni. Oh, yang ni kena open.
Yang 1 open, yang 0.1
open juga.
Open juga.
Sebab dia punya tu macam mana? Sebab kita punya function macam ni kan, dia macam dia tak include jugalah sebab dalam ni, sebab dia tak mati terus 0.1 ni. Dia ada union 2 ni. Kalau yang ni faham kan? Sebab 0.1 kita consider 1 dia open. But for this case, sebab kalau kita tutup, maksudnya kita tak boleh pecahkan. Ni. Sekejap. So you have 0.1 dengan 0.9. Okay. You divide this. If you start from here, ni mesti kena include So yang ni you have to open lah. So kalau ni you start here, you cannot tutup kat sini. Sebab dia kena open kat sini. Because this is the last point yang include dalam dalam objek ni. Nak selamat selalunya we put at the end tu kena 0, 1 lah. For this case sebab dia in the same element. Ni satu elemen lengkap satu, dia boleh bawa semua masuk dalam macam ni. Okay, you have 0.3 dengan 0.5. So if you project, you can get the whole thing. Ni the whole thing dalam the whole thing maksudnya satu sebiji, the whole length of the interval tu pergi ke 0.5 dengan 0.7. Ni masuk situ. So 0.5 tu included kan sebab dia ada ni. Dia ada dia punya tu square bracket at the end. So kalau the whole length boleh masuk dalam ni the same, so we can put the square bracket. Tapi kalau for this case we cannot because dia ada pecahan. Bila ada pecahan, that means one of the bracket mesti open. Kalau tak, dia tak boleh separate. Okay. Alright. Good questions. Okay, another example. Ya.
Tak faham lah. Macam mana tadi boleh jadi satu invertible, satu lagi non-invertible? Doktor kata yang atas tu invertible.
Ya, memang invertible. Sebab dia one function ke the whole length tu boleh dapat the whole length. Ni tak faham kat mana?
Kan doktor buat kat atas tu T alpha X, dia major preserving dengan invertible. Lepas tu yang bawah tu.
Ya. Non-invertible. Okay, so selalunya we want to find, okay, for this case, T ni saya bagi contoh yang T alpha yang non-invertible. Saya nak yang invertible. Ni. So, okay. Tak nak confuse Okay, kita write this one as invertible saja. MPT saja. Okay. So, so for this case, I want to consider MPT je. Okay. So, I find alpha is 0.2. So in this case, kalau alpha 0.2 and you have this segment, so that means this is invertible. Kalau I have alpha is 0.2 but with this segment, but this is non-invertible. So for this question, actually I want to list which element, which segment that give me invertible punya transformation. So at least you can decide lah which one invertible, which one non-invertible by this transformation. Okay. Okay, let's say next example, you want to find this pre-image of alpha. Find the inverse. So first you have to verify that T minus 1 alpha is equals to X plus. So kalau T alpha is equals to X plus alpha mod 1. So your T inverse should be X plus 1 minus alpha mod 1. Is that okay? So if you can verify this is equals to the x plus 1 minus alpha, that means you can find the inverse lah. Try verify. Okay, number 3. Now we want to find the entropy. Okay, with the same transformation here, T alpha. So now I want to find for alpha is 0.5. What do you have? T alpha square is equals to what? T of T alpha, right? So T alpha is x plus. So your alpha now is 0.5. So x plus 0.5. Mod 1. And then you substitute back, right? Because this is a composition of two transformations, so you have another x plus x plus 0. You will have x plus 0.5 plus 0.5 mod 1. Betul?
Betul.
Okay. So what is your transformation? T square alpha.
X.
Yes, you will have x. Sebab x plus 1 is mod 1, right? So kalau mod 1 mod 1 jadi kosong lah. So jadi x. So what can you infer from this transformation? T square alpha dapat x. Maksudnya T square alpha x dapat x. So this is identity. Maksudnya periodik lah. This is periodic. So nak cari entropy periodic function, you can just use the theorem ke lemma tadi. And say that h of t is 0.
H of t ke h of t square?
T square, sorry. T sebenarnya. Ni h of t square alpha equals to h of, you show already right? Tp is equals to id kan? Betul tak? H of id is 0. H of t lah sebenarnya. Okay. Alright. What if we change? Okay, we change the parameter alpha again. So let's say what happens if alpha is 1/3? So periodic or not? So if it's periodic, what is the period? So first you have T alpha x is equals to x plus alpha mod 1. So if alpha is 1/3 x, so you should find how many period to get back x. Let's try. So this is x plus 1/3. So then you find the square, right? t square of this. This is become t of t1 over 3 of x. Correct? So I have t1 over 3 of x plus 1 over 3 mod 1. And this one is x plus 1 over 3 plus 1 over 3 mod 1. So this become x plus 2 over 3 mod 1. Agree?
Yes.
Okay, what? And then you should find another, right? You should do another iteration because you cannot find tak periodic lagi. Dia tak equals to x lagi. So cari lagi. So 3 power 3, t power 3 x. So I have t 1 over 3 of t squared 1 over 3 x. So I have t 1 over 3 of x plus 2 over 3 mod 1. And this give you x plus 2 over 3 plus 1 over 3 mod 1. Agree?
Yes.
Okay, so
Dapat X balik.
dapat x balik. So you have 1 x plus 1 mod 1 which gives you x. So this is your, so we know that alpha, even alpha is 1 over 3, you know this is t, our t is periodic. So what is the period?
3.
3, yes. That means you have to do 3 iterations to get back to x. Okay? Okay, now, so what happens if your question is like this? For any alpha, let's say 2021. What do you think happened to this alpha? Is it periodic? Sekejap,
No.
2021 pula. Sekejap. I should write this. Periodic ke tak?
Yes.
Yes, this
Yes.
one is periodic. So how many period?
2021.
2021. So it doesn't matter what alpha is as long as it between 0 and 1 segment. Okay. But actually, if you look at this 1 over 2021, if you divide, what can you have? What is the value? Dia jadi rational number ke dia jadi irrational number? Cuba divide dengan calculator, dapat berapa?
Irrational.
Rational lagi kan?
Irrational ke irrational? So apa contoh irrational number?
Pi.
Irrational, irrational number you should have macam pi. Lagi?
Exponent.
E. Lagi?
Square root 2.
Square root 2 and so on. Betul? Banyak. So that is irrational number. Kalau rational number?
Can be written as fraction.
Yes. So you can write P over Q, right? Where P and Q is greater than 0. And P and Q is taken from Z. P and Q greater than 0 and Q must be taken from
natural.
Yes, natural number. Okay. So kalau irrational, kita tak nampak pattern. Pattern dia punya point tu macam pi ni berapa point dia kan? So we cannot see the pattern. Maksudnya kita tak boleh nak tulis dalam bentuk fraction yang nombor bulat. But for P and Q we can. So kalau in this case your question alpha is 1/2021, so you will have berapa tadi? 0.000494805 kan? So yang tu rational number. Rational number. So if your conclusion dia, if your alpha is rational number, okay, so you can get periodic. That means for any Q iterations, you can have your transformation T here is identity. Okay, and your entropy is equals to
0.
0. This is the conclusion. Kalau irrational, cannot. You cannot find, this is not a periodic, therefore you cannot simply find your entropy equals to 0. Dia kena ada cara lain lah. Okay, this only works for rational number. Periodic case only works for the rational number.
Doktor.
Ya. Yeah?
Untuk transformation tu jadi identity, dia kena Q times kan, tu maksudnya.
Iterate Q times.
Iterate Q times. Kalau P dia lebih daripada 1, macam 2/3 ke 3/4.
2/3 tu rational ke tak?
Rational.
2/3 rational. Okay, kalau 2/3 maybe dia punya calculation lain sikit lah. Bukan 3 kali. Macam straight away you can get 1/3, 1/2021 semua kan. Tu mesti akan ada some extra calculation. Mungkin bukan 2 kali, mungkin 5 kali ke 6 kali. So as long as the value is here is rational, PQ ni rational. So kalau 5/5, you can get your apa tu, T is periodic.
Maksudnya bukan Q times lah iterate untuk dapat identity.
Okay, kita nak tengok, nak try. Maybe Q times, sebab kalau daripada sekejap maybe Q times. Kalau daripada general conclusion ni, is stated that Q times we will get identity. It doesn't matter P1 ke 2 ke 3 kan? Okay, try check. So let's say alpha is
2/3.
So T of 2/3 is X plus 2/3 mod 1. So T power 2. X is T of
X plus 2/3.
Teruslah tulis So this X plus 2/3 plus 2/3 mod 1. So X plus 4/3 mod 1. So kalau 4/3 akan jadi apa in mod 1?
1/3.
Yes, you have 1 X plus 1/3. And then you go again 3x. So I have X plus 1/3 plus 2/3, betul?
Betul.
So you will have X plus 1.
Wow.
So the same. So it doesn't matter what values of P over Q, as long as they are rational. That means your function here T. So TQ will become periodic.
Alpha ni dia tak ada range dia lah. Daripada
Ada.
0 hingga 1 je.
Ada tadi 0 hingga 1. This one. Ni kat example number 1. Ni lah. Alpha pun kena between 0 and 1 lah. Sebab X pun between 0 and 1. Okay. Good question. Saya tak pernah check pun. Tapi kalau ikut pada conclusion dia memang sama je. Alright. Any question so far until this part?
Ada.
Boleh. Okay. So okay, so for the case of conclusion, for let's say if you have isomorphic conclusion, so let's say if you have isomorphic transformation, if two transformations have the same entropy, if two T's have the same entropy, is it isomorphic? So kalau two transformation are isomorphic, that means they have the same entropy, betul? But otherwise, if two T's have the same entropy, adakah they are isomorphic? No, not true. Because two isomorphic cannot be, probably don't have the same entropy, because if you can see in previous calculation tu akan ada satu yang saya tunjuk, tak ingat yang mana. Ada yang saya tunjuk they are isomorphic tapi they have the different entropy. Macam Bernoulli shift dengan apa lagi satu? Bernoulli shift kalau dalam ni dapat log, dia dapat dia punya function is this kan? H of T is minus pi pi log pi, betul? Ni tak sama dengan sebelum ni. Let's say Becker's. Becker's ada, kita tak kira entropi dia, kita kira benda lain kan. Apa lagi satu? Bernoulli shift. Kalau Bernoulli shift one sided kan? Yang log R tu. Log R dengan log 2. So kalau Bernoulli shift yang ni ada kita divide pada 3, maksudnya 1/3, pi dia 1/3, 1/3, 1/3. So dia akan dapat lain. So kalau kalau you divide another one as 2, apa tu? Another one tu sebagai you divide as 2 partition, 2 element in the partition, and then you got log 2 kan? So they are different. Tak semestinya the same entropy, they are isomorphic. Tapi kalau isomorphic, yes, they have the same entropy. Generally ingat yang itulah. Kalau isomorphic dulu baru you can have the same calculation apa-apa. Tapi kalau bukan, otherwise it's not true. Tapi untuk case Bernoulli shift, if two Bernoulli shift have the same entropy. So this is isomorphic. Maksudnya untuk kes Bernoulli shift saja. Kalau Bernoulli shift tu the same entropy, they are isomorphic. Tapi untuk kes yang Bakers, diadik, ariadik semua tu, they are different. Oh, ni saya tersalah bagi tahu lah ni. Maksudnya ini we cannot consider Bernoulli shift. Bernoulli shift special. So we should consider for diadik, ariadik, triadik, Bakers, and so on. Nak selamat show apa tu isomorphic dulu. Kalau isomorphic you can talk about entropy. Tapi kalau entropy you cannot talk about isomorphic because they are not isomorphic. Okay. I think we have done. Any questions?
Tak ada.
Tak ada. Okay, so for final exam, there will be berapa questions? 7, I think 7. From the not lah some beginning sangat. So the part yang Dr. Fatimah tu ada bahagian Bernoulli shift sikit and ergodicity something. And then part saya from the week 8 lah, week 8 until today's class. So Dr. Fatimah punya question 1, saya punya question 6. Okay, so all the best. I think we have finished our class for lecture. So maybe kalau you want the apa tu namanya review, bukan review, ulang kaji.
Revision.
Revision. Kalau revision tu, I can share you Prof Nasir punya video link because in the last week 14 tu dia revise lah from the beginning. So better to hear from him lah. Sebab saya tak cover in the beginning tu kan. So dia akan cover from the beginning. So maybe you look at the video to recall some of the memories lah untuk this course punya topic. Okay, so I will share you the link next week. So next week, yes, we have hari Selasa, we will have quiz. So start at 11, 1 hour and 20 minutes quiz. So you have 5 questions, cover entropy. Make sure you remember the formula for the entropy, conditional entropy, and also the relative entropy sikit. Lepas tu calculation lah, soalan saya pretty straightforward. And then if you can do the home task because my question ada melibatkan home task juga. So maybe insyaAllah you can do it. Okay. Alright, so I think that's all for today's class. See you insyaAllah on Tuesday. Okay, thank you. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you, Dr.